Have any of you guys ever dealt with a lot of chili ever? I've made my own, started to make my own hot sauce today, and I've cut up only maybe kilo and a half of chilies, but whew. Hey guys, I hope your weekends have gone well. I'm back with another tutorial tonight to continue on with our Parametric Pliessnig project. You'll have to forgive me. I've been cutting up a lot of chili because I'm making hot sauce, and it's just all on my hands. So if I start rubbing them, that's why. So last time we looked at getting our what do we call it? Our carcus sections looking really, really nice, and subtracting all the rail geometry from them, which is great. So now we essentially have to do the same thing for our carcus rails themselves. So take notches out all along here so they can sit in there very nicely. So what we're going to do is firstly grab go back and grab some of the curves we generated before for the rail geometry. So I'm just going to set this up here, and then we're probably going to need our material thickness, which I know it's 18, but I just have to remember where I needed it last time. Here, amplitude. Oh yeah, here it's in one of our inputs to care about. Sheet material thickness 18. Awesome. And there's only we're going to be needing our. Remember we turned our inner shape into polylines. We're going to be needing those curves. So the first thing we're going to do is explode these curves out. Awesome. And then what we're going to do is we're going to curve closest. Curve closest point. So for each of these vertices, we want to find our closest point, and we're going to be grafting them. Oh yeah, this is so we can generate some perp frames all along here quite easily. And there's probably other ways you can do this. This is just mine. And then we want to do a similar thing down below. On the other curves. So what that is going to involve is essentially simplifying and just some more simplifying for good measure. Maybe one more simplify. Awesome. Great. Okay, and then what we're also going to go up here and do is deconstruct plane, and we're going to deconstruct all of these, and we're going to construct a new plane. And I've also forgotten that this step isn't needed anymore, so I'll leave it down there. Okay, cool. So let's rebuild this plane with the same origin, but we want to make it we want to flip it 90 degrees, and then we're going to make the Y along the Z. like so. This is just adjusting, the plane in which we're going to start to draw a lot of boxes in a short while. And I think I just need to flip this matrix back a bit to the right. Well, to the other context, because I'm about to adjust all these planes kind of like in this direction and in this direction, rather than across the whole entire design. And I'm going to flip all these planes. And I'm going, because it's Sunday, I'm going to be lazy and not actually compute it. I'm actually going to type it in myself, which is like a no-no. Like I'm typing this pattern in because I know this pattern works. I've got to turn multi-line data on. So what it's going to do is it's going to make sure that's we're not flipping any planes at the moment. I'm pretty sure, or only the Z. Sorry, that's the default. But what we're going to do is for every one of these, because I know there's 6. Because there's 6 points along here. These ones aren't going to be flipped, and these ones are going to be flipped. And is there a difference? Yeah, you can see it. And we will flip these back now to be in like along the rail geometries. Yep, and we can start to draw. I think it's a what kind of box are we using? No, not a center box. We want a domain box. Awesome. And then what we're going to do is use our favorite number, our sheet thickness, and then we're going to construct just a little quick one I made. Construct equal domain. It takes, I think I mentioned before, it takes 18, goes -9 to +9. That's useful when you're dealing with things that you need to be in the middle. And I'm going to do this, and I'm going to make another one, just maybe a number like 30. We're starting to create our subtractive geometry now, and it'll start to take shape. And then what I need to do is construct domain. I'm going to construct a normal domain and go from like 33. I think we're going to go to it's either 1 or 0. I think we want 0, like that. That's looking like it is mostly working. So now we just need to take our 3D rail extrusions, which should be up here. Bring them down here because we're going to start to set up our Boolean operation. And you can see if I zoom in closely, this may or may not have worked. What is going on here? I could have fucked this one up. I could have needed to go 1 1 1 0 0 0. No. Okay, guys, we ran into a little bit of a problem there. I think it was the order of my rail curves. It was a little bit different to the one I had the example drawn up. So what I've done is I've just replicated that list of zeros and ones I had previously, and you can see like changing each one. I can start to flip the Z where I need to. And see, I want something where they all explode out or extrude out from the curve outwards, which is good. And I should have that now, and I should be able to perform my differencing operation. Solid difference. And 6 this. I think I just needed it. Oh no, it should be all good to go. Let's have a look. It might take a few seconds because there are quite a lot of shapes. Again, you could this is probably the easiest way to do it, but it is a little bit computationally intensive. There are many other ways you could do this, but we'll see how we go. Oh, there we go, 20 seconds. And there we have it. All our differencing geometry's been done, which is good. So let's have a look if it actually matches up with our other ones. Oh, apart from a little bit there, but yeah, look, that's a pretty good result. It should difference out nice. Well, it has difference out pretty well. So now we've got something we can nearly start to fabricate. So all we have to do, well, we're halfway there, I guess. All we have to do is cut all our rails up, and then lay them out for nesting, and then we just need to cut these up as well and lay them out. So cool. Thanks, guys.